Today, we are diving into one of the biggest threats to our planet's water systems, hydrocarbon pollution. We're going to look at what it is, the incredible damage it causes, and the toxic legacy that sticks around long, long after a spill seems to be gone. So, we've all seen those terrible pictures of oil spills, right? But what is actually happening under that dark, slick surface? What really goes down when oil and water, two things that famously refuse to mix, are slammed together on a massive scale? Well, let's break it down. All right, first things first, let's meet the villain of our story, the hydrocarbon. It sounds complicated, but at its core, it's just a simple compound made of hydrogen and carbon. The problem is, these simple molecules, which we get from crude oil and natural gas, become a massive headache when they escape into the environment. So why is this stuff such a huge deal? I mean, it's not just that it looks messy, right? Hydrocarbons have this unique set of properties that make them an especially dangerous and stubborn threat in our oceans, our rivers, and our lakes. To really get the danger, you have to look at the pollutants profile. You see, hydrocarbons are hydrophobic, a fancy way of saying they hate water and won't dissolve. That's why they create those infamous oil slicks on the surface. They're also persistent, meaning they stick around for a really long time, and they're flat out toxic to living things. And that last one, bioaccumulation, oh, that's a slow, creeping danger we're definitely going to get into. So, where does it all start? How does this journey of destruction even begin? Let's trace the path these pollutants take, from the moment they're spilled all the way into the heart of our ecosystems. You know, while those huge oil tanker spills are what grab all the headlines, the sources are actually way more common. It's things like routine shipping activities, wastewater from factories, and even urban runoff. Yeah, that little rainbow sheen you see in a puddle in a parking lot, that's hydrocarbon pollution from cars. And you better believe it all eventually washes into our waterways. Once it hits the water, oil starts this really dynamic, destructive dance. First, it spreads out, creating that thin film. The lighter bits actually evaporate into the air, but the heavier parts start to emulsify. They mix with the water to create this thick, goopy sludge. And eventually, the absolute heaviest parts sink, dragging all that pollution down to the bottom of the sea. And this journey, this path of destruction, leads us to the really tough part, the absolutely devastating impact that oil has on an entire ecosystem, from the tiniest plankton all the way up to the biggest whales. The most immediate effect of a spill is this. An oil slick isn't just floating there looking ugly. You have to think of it as a liquid blanket that is actively suffocating the surface of the water, cutting off an entire world of life from the air it needs to breathe. So this suffocating blanket, it kicks off a whole chain reaction of destruction. It blocks sunlight, which stops photosynthesis for the tiny organisms that are the very foundation of the ocean's food web. It literally stops oxygen from getting into the water. And beyond that, the oil itself is poison, damaging fish gills and physically coating and killing vital habitats like coral reefs and mangroves. And for the animals we can actually see, the impact is just as direct and, honestly, heartbreaking. When oil coats a bird's feathers or a sea otter's fur, it just destroys their natural insulation. It's like taking away their winter coat. They can't stay warm anymore, which almost always leads to fatal hypothermia. Okay, remember we mentioned bioaccumulation? This is where that invisible threat really becomes terrifying. Those persistent hydrocarbons get absorbed by tiny little organisms. Then, a bigger fish eats a bunch of them, and that toxin builds up. This happens again and again, all the way up the food chain, getting more and more concentrated at every single step, eventually reaching top predators. And yeah, that includes us. So, when you're faced with this kind of disaster, what can you even do? Well, that brings us to the human response, our ongoing uphill battle to try and clean up our own messes. We basically have a three-part toolkit for cleanup. First, there's the mechanical approach, using these long floating booms to corral the spill and then skimmers to literally suck the oil off the surface. Then there's chemical, using dispersants to break the oil up into smaller drops. And finally, there's bioremediation, which is pretty cool. It uses naturally occurring microorganisms that actually eat the oil. But let's be real, trying to clean millions of gallons of oil out of the open ocean is a monumental, if not impossible job. And that's exactly why prevention is so critical. Things like stricter rules, safer ships with double hulls, better wastewater treatment, and systems to detect leaks early, these are the things that stop the disaster before it can even start. So if you take away just one thing from all of this, let it be this.
Hydrocarbons aren't just some other pollutant. It's their unique, terrible combination of being toxic, being incredibly persistent, and being physically disruptive that makes them a fundamental threat to all life in our waters.
And that leaves us with a pretty heavy question, doesn't it? Our cleanup methods are far from perfect, and they can never truly bring a dead ecosystem back to life. So, when it comes to protecting our oceans from oil, is prevention not just the best option, but maybe our only real solution? It's definitely something to think about.